All right, so today, well, in this lecture, we're doing 8.1 systems of linear equations and two variables. So here we have an example of a system of equations with two variables, x and y. And so when you're talking about the solution for this system, we're not just talking about a solution or ordered pair that works for one equation. It has to work for both of them. So in other words, if I look at the ordered pair 5, 1, 5, 1 works for the first equation because 5 plus 1 is 6. And don't forget, each variable, the first one is x, second one is y. But it does not work for the second one because 5 minus 1 does not equal to 2. So the solution that will work for both of them is 4 and 2, the ordered pair 4 and 2. 4 plus 2 is 6, 4 minus 2 is 2. So that's what we're talking about, a solution for a system of equations. It's a solution that works for both of them, an ordered pair that works for both of them. All right, so we're going to have three methods that actually can do it, but we're not using one of those methods in this section. So you can solve the system by graphing, solve the system by substitution, or solve this system by addition. So if you were solving by graphing, you would graph both lines and where they intersect, that would be the solution. But once again, we're not using that one. You see that I have right there, not using solving by graphing. This section emphasizes solving by substitution and solving for addition or solving by addition. Some say elimination. So if you see the term elimination, you can put that up here, solving by addition or elimination. So those are the same thing, solving by addition or elimination method. All right. So we're looking at those two methods, the substitution and the addition method. Now, in either one of those methods, doesn't matter which one you're using, there will always be three possible scenarios. The first scenario is you solve it and you get one solution, and it's that ordered pair. So don't write one solution, you'll write the actual ordered pair. It's not spelled ordered. So you write the actual ordered pair just like before. Our solution was 4, 2. So don't write one solution, write the actual ordered pair, just trying to prevent any type of situations, any type of misconceptions that may happen, in the future. So you write down this actual solution. Now, the other two scenarios here, if it's no solution, you write down no solution, or infinitely many is the other option. So those are your three scenarios that could take place no matter what method you use. Those are your three options, those three possible outcomes. One solution, no solution, or infinitely many solutions. All right, so let's look at the first method that we're going to discuss is the substitution method. So we're going to solve one of the equations for one of its variables. Then we're going to substitute the result from step 1 into the equation not used. Solve for the remaining variable. Then we're going to substitute the solution from step 3 into the equation from step 1. Solve that. And then check, when we're talking about checking, all you do is take your order pairs, plug them back into the original equations of the system, and see if it works. Just like we did the 4 and 2. 4 plus 2 is 6. 4 minus 2 was 2. All right. So let's look at the first one. First example, 5x minus 4y equal to 9, and x minus 2y equal to negative 3. So the first step is to solve one of the equations for one of the variables. It doesn't matter which one, doesn't matter whether it's x or y, first equation or second equation, just have to accomplish that goal. Normally I call the first equation, equation 1, second one, equation 2. So I'm going to look at equation, not equation 1, equation 2, because we see right here, the easiest one to solve for is this x. All right, now it doesn't matter if you choose solve for y from this equation or anything else, but you do want to choose the easiest route possible. Notice this x is the only one by itself, so I'll use that one to solve for. So I'm using the equation, I'll probably go dark blue. Using the equation 2, and I'm going to solve for x. And I'll do that by adding 2y to both sides. x is equal to 2y minus 3. So that's the end of step 1. Once again, we're going to solve one of our variables, one of our equations for one of our variables, doesn't matter. So next step is we're going to take the other equation and solve what we just got into that equation. So we used equation 1, 2 in the last last step. So we're going to start off using equation 1. So that's 5x minus 4y equal to 9. And now here we know what x is equal to. We have a representation for x. X is equal to 2y minus 3. So we're going to plug in x, plug in 2y minus 3 where I see x. Everything else stays the same. So you see we got y, 4y, we still have the 9, we still have 5. The only thing that's different is now instead of x, we have this expression 2y minus 3 because that's what x is equal to. All right, so this is the end of step 2. All right. So that's what we have for step 2. Now, step 3, we want to solve for the remaining variable. So notice now all we have is y involved in our equation. So we're going to solve this equation for y. Go ahead and distribute. 10y minus 15 minus 4y equal to 9. Combine your like terms. 6y minus 15 equal to 9. Add 15. Six y equal to 24. Divide by 6. Y is equal to 4. All right. So this should be step 3. Solve for one of our variables. And step 4 should be, we're going to substitute what we have for step 3 back into the equation from step 1. So this is step 1. X equal to 2y minus 3. And now y is 4. And that's 5. And so that's step 4. So our answer is 5, 4. So X is always first, then Y. All right. All right, so that's that one. We'll come back and do another one, but I want to go ahead and address the other method, give you the steps for that one. All right, so Should write the equation. All right, so looking at the first two steps, it says if necessary, you want to rewrite both equations in the form of ax plus by equal to c. Step two, if necessary, once again, multiply either or both equations by a non-zero integer that will enable one of the variables to cancel when added together. So in other words, you want to create the scenario, see what I have here in the red, -5 and -5x and +5x, or 10y and -10y. So you want to create that scenario. All right. All right, so then you're going to add your equations. After that, solve the remaining equation. And from there, you'll have a solution, just like we had that y before. You back substitute into the result from step 4. Well, back substitute the result from step 4 into either of your original equations. Then we'll solve. And of course, we always ended up with checking. All right, so let's try this out. All right, so we have 3x plus 2y equal to 48. And then we have 9x minus 8y equal to -24. So what we want to do is create this scenario that I'm talking about right here, where when we add our equations together, one of our variables will cancel. So I have a choice here. Either I can cancel out my x or I can cancel out my y. And we have to ask ourselves which is the easiest route in order to do so. Doesn't matter which way you go, just have to make sure that you do it correctly. All right, so I could cancel out my x. If that's the case, then I need to turn this 3 into -9x. Or I could cancel out my y's. If that's the case, then I need to turn this 2 into a +8y. All right. So since I already have a negative right here, I'll just go ahead and multiply this whole equation by 4 so that I can cancel out my 8. Now remember, if you're going to multiply it times one term, you have to do it to each term. Can't just multiply it to one term. So multiplying 4 to each gives me 12x plus 8y, and then 4 times 48, 192. So this is my new equation 1. All right, because this is equation 1. This one is equation 2. So now I'm going to take that and add it to equation 2. So go ahead and add those together. Get 21x, 8y, negative 8y cancels. And 192 minus 24 gives you 168. So now I can solve this. 21x is equal to 168. Divide both by 21. X is equal to 8. So that's my first part of my ordered pair. Now I take that x equal to 8 and plug it into either one of these equations. It doesn't matter. Just have to choose one. So I'm just going to use equation 1 because they're smaller numbers. I got 3, 2, instead of 9 and 8. So once again, it doesn't matter. So we have 3x plus 2y equal to 48. Make sure I got my numbers right. 3x plus 2y equal to 48. Yep. And I'm going to plug in for x. So that's 3 times 8 plus 2 times y equal to 48. 24 plus 2y equal to 48 minus 24. That's 2y equal to 24. Divide by 2. Y is equal to 12. So my answer is going to be 812. All right, so I want to cover 2 more situations that could occur. Remember we talked about ended up having no solution. All right, so we'll talk about the scenario that will create no solution. Remember we talked about 3 different ways, 3 different outcomes that could occur. And so no solution is one of them. We did a few examples of one solution. So let's talk about what occurs when you will get no solution. All right. So we have 4x plus 6y equal to 12, 6x plus 9y equal to 12. So doesn't matter which method you use, you'll still get the same result. I'm going to go ahead and use the elimination or the addition method here. And then in the next one, I'll use the substitution method. Like I said, it doesn't matter. You just have to be efficient in what method you decide to use. So once again, we have a choice, either cancel out your x's or cancel out your y's. I'm going to go ahead and cancel out my x's. Once again, it doesn't matter. You just have to make a decision. Now, you also have to make a decision on what you're going to turn those numbers into. I can't turn 4 into 6 easily. Neither can I turn 6 into 4. But what I would do is look for a multiple of both of those numbers. So I could just multiply 6 and 4 together and use 24, or I can do 12. 12 is the smallest number that both 4 and 6 can divide into evenly. So it's the same thing as if you're finding your LCD. If I had 4, 1 over 4, 1 over 6, and I wanted to add them together, the LCD would be 12. That's the smallest number that both 4 and 6 can divide into evenly. Same thought process. Same thought process. So I'm looking to change both 4 and 6 into 12. Now, remember, one of them has to be negative and the other one has to be positive. Once again, it doesn't matter which one. I'll just make a decision. So I'm going to do the first equation and multiply it times 3, excuse me. And remember, whatever you do to one, you have to do to all terms. So that's going to be 12x plus 18y equal to 36. And then the next one, I'm going to multiply each term by -2. All right, multiplying times -2, that gives me -12x minus 18y equal to -24. All right, once again, we did negative because we had to get a -12. Or I could have used -3 right here and got my -12 and then use +2 right here. Just that one of them has to be negative, the other one has to be positive. If I go back to our last example, I didn't have to worry about that because all I was doing was changing this to an 8 by multiplying it times 4. And I already had a minus sign sitting in front of that 8. So the negative was already there. So just going back, just make sure we understand what's going on. So first equation, 12x plus 18y equal to 36. Second equation, -12x minus 18y equal to -24. And we're going to add these together. Separate them by green. All right, so adding these together, what we notice here is that 12x and -12x will cancel. 18y and -18y will also cancel. All right, so that would leave me with 0 on the left side of my equation. 36 minus 24 is 12. That's on the right side of my equation. So I have 0 equal to 12. And this right here is a false statement. And we've seen this before. So when your variables cancel and you have a false statement, your answer is going to be no solution. Yeah, too big. I'll just go square. All right, so make sure you're good with that. So variables canceled, ended up with a false statement. Your answer is no solution. Notice your answer isn't false. Answer is not false statement. Your answer is no solution. All right, so let's look at the other scenario. Infinitely many solutions. All right, so last one. We have y equal to 3x minus 2, 15x minus 5y is equal to 10. So a lot of times which method you choose will be dictated upon what you're given originally. If you look at what we have here, this was pretty much set up to do solving by addition. Nothing really easy to solve for here. Here though, this one is already set up for substitution method. We have y equals to 3x minus 2. So I will go ahead and go with that. So we have y equal to 3x minus 2. We already have our variable solved for. Now we can take the other equation, which is 15x minus 5y equal to 10. Trying to do something. Okay, it didn't work. So now we can just plug in for y. We know what y is equal to. Y is equal to 3x minus 2. So we got 15x, 5. Let me bring that down some. times 3x minus 2 equal to 10. Now we can go ahead and solve that. So we're going to distribute -5. Make sure you don't lose that negative in your distribution process. So we have 15x minus 15x plus 10. -5 times -2 is a positive 10 equal to 10. 15x minus 15x cancels. And that leaves me with 10 equal to 10. And that is a true statement. I can write that better. All right, so let's look at what happened here. When your variables cancel, end up with a true statement. Your answer will be infinitely many solutions. All right. Write some of this a little better. So those are your examples for this section. Let me know if you have any questions.